me just tell you a little bit about coding blocks. Any of you are students here? Okay, a lot of you. You guys know about coding blocks? How many of you know about coding blocks? Oh, almost all of the students here. Okay, so we are software development bootcamp. We've been running for more than about 3 years now, started in 2014. We started with offline physical spaces. Now we have online programs. So people are learning mobile development, web development, machine learning, all of these kind of things at coding blocks. And of late, like we have seen a lot of people learning in purely offline modes where they are consuming the content, doing the assessments, all of that stuff. They're doing it completely online without ever having to come to our physical centers. We have like more than 2,000 daily active online course users. So till now we have had like more than 10,000 bootcamp graduates, of which more than 2,000 of them are right now in some Fortune 500 companies, some of India's top companies, and we have now 4 physical centers, and it's completely bootstrapped. We are not a funded company. So I'd like to show you some of the technical parts of this, how like the underpinnings of it, how we are able to do that. So this is an example. This is a very popular website of coding blocks, our most popular website that's used all across India and even outside India a lot, which is the coding blocks online ID. So, and I can show you something, like, for example, I change the input, run the code, and see output comes. So that's the speed at which the online ID runs. So basically, your code is getting pushed to the server, it's getting compiled, and can do that with a lot of languages, C++, Java, Python, okay, all of that. And it's one of the fastest online IDs. You can check out some of the, even the big players, you can compare the speed with the coding blocks one. Some of the fastest online IDs that are available. That's why I've seen a lot of colleges, they are internally using that these days. We have seen more than 40% of our online course students, they don't even install GCC on their laptops anymore. They are learning the course completely, trying out code on the online ID, completing, like, learning about a lot of complex data structures and all, completely using the online setup. So, how do we get this kind of system which can scale to something like 2000 RPM requests, or where the code is supposed to be compiled and you get results back and all of that stuff happening? So let's talk about the infrastructure. It's an overview, not just about the ID part. So like, for example, we have a lot of apps. We have an app where people are consuming videos, learning things. We have an app where the ID one is there, people are trying out code. We have an app where there's an online contest where people are making pull requests to GitHub, and there's a contest somewhat like, do you have Hacktoberfest, which DigitalOcean helps organize. Similarly, we have a contest called Boss, where during the summers people are contributing code and they get some bounties, they win some prizes. And it's a kind of microservice kind of architecture. There are separate APIs, there's a single authentication server, there are DBs, they're all connected to each other. So how do we go about doing this initially? Like, our entire tech stack is built on DigitalOcean. It's more of like this. It's like every product that we start building, it's just one droplet. Then like more users come in, you have to scale. Starts off in a very manual way. We make multiple copies of that droplet, multiple images, and then all of that stuff is behind a load balancer. But the problem with this is that this does not scale on demand. Like, we know that there's going to be requirement for scale. We make a copy of the droplet, we make a load balancer, something like that. But what if we're talking about the online ID, where the demand graph can go up and down in a very haphazard way and in very huge quantities. So that's where we have an architecture where we have, for example, an API where the requests are coming in, it puts stuff onto a job queue. So a job queue where it's basically a two-way queue. Then there's a taskmaster, and there are a lot of engines. So there's a C++ engine which can compile C++ code, there's a Java engine which can compile Java code. Like that, there are many of these engines. They are giving this response back, comes back to the job queue, to the API, comes to your screen. This entire thing that you saw in sub 1 second time that was happening, this entire thing is happening. How does this thing scale? So that's where the Kubernetes architecture comes into play. I think DigitalOcean has a very nice managed Kubernetes system which they are rolling out right now. We, though, have already been using Kubernetes with DigitalOcean in production already for some time. We have just been setting up Kubernetes manually on our droplets. So each of these setups, like the taskmaster plus all these engines together, is like a Kubernetes node. So we have our API server, and there can be n number of nodes, and you can set up some configuration inside your Kubernetes master, number of requests that are coming in per second. It will make extra copies of your nodes. So each node is basically a droplet. So whenever the load increases, droplets increase. When the load decreases, just droplets get destroyed. So at all the time you are running sufficient number of droplets, you always have sufficient processing power to go through these requests. So when we are building this entire thing, that coding blocks, our infrastructure that supports offline, online, all kind of courses. So why DigitalOcean? Why the choice for this? So first thing, like when you start building a server, you look up cloud providers who are providing servers, and you read up about a lot of things like, object storage, elasticity, on-demand RAM, data warehousing. The thing is that when you start building a server, you don't need all of these things. What you need is, you need a server. And that is something that I feel DigitalOcean has got bang on. When you start building up, basic backend you want to build on, there is a droplet, one click, you can deploy, you can start building things. And all of these features are actually available under the hood. They are all there. Okay, you're not losing out on any of those things. But when you're starting on, you don't need to read a manual on how to use DigitalOcean. You can just start off with. So that also helps when you have a bootstrap team, very small team, junior developers coming in. You don't need to teach them DigitalOcean. They know how to run Linux on their laptop. They know how to run DigitalOcean. That's it. So it's very easy to grow with the team. You don't have to train the team a lot on how the DevOps is happening. You don't need to have specific sysadmin people in your team. Everybody is a sysadmin. Okay. And second thing also, for people who are at the growing stage, people for whom cash is not something that you are able to splurge, you don't have like huge profits. So pricing should not be something that is surprising. We run a contest and we get a lot of users coming in for that contest, and suddenly that month we have a 10 lakh rupee bill for our servers. That can be pretty shocking. I think DigitalOcean pricing, I think it's very, very transparent, and if you remove all the first year credits that you get from a lot of the cloud providers, and even DigitalOcean provides. But when you really have to pay for it, DigitalOcean is one of the cheapest providers for basic compute instances that's available out there. In fact, the amount of money that we spend on our cloud infrastructure is less than the amount of money that we spend on our code hosting, the amount of money that we spend on our application monitoring services, and the amount of money that we spend on our business email, like @codingblogs.com email. All of those things are costlier than what we spend on DigitalOcean to manage our servers. So that's pretty great. For an early stage startup, for a mid stage startup, or I think for anybody, I mean, saving money is very important. We really love the API that DigitalOcean has. In fact, a team from Coding Blocks, we went to one of the DigitalOcean hackathons that happened in Delhi. We had even made this app. We use that a lot at Coding Blocks itself. We have a DigitalOcean app which we can use to create droplets, delete droplets, manage droplets directly. Like the entire DigitalOcean dashboard as you see on the website, the same thing on an app. It's all possible because everything that you can do on the DigitalOcean dashboard, all of that is available by the DigitalOcean API. So on the app, you log in with your DigitalOcean account and control everything in your account using that. So even if you have like Kubernetes nodes in your DigitalOcean stuff, you can scale that up and down, all of that stuff you can do using this. And finally, again, for people who are just learning DevOps, people who are just learning to set things up, creating new backends, junior developers, the DigitalOcean community is a really helpful thing. And more than anything else, I think that even if you are not specifically installing something on DigitalOcean, if you just search for even generic terms, you search for how to create a Kubernetes cluster. You're not searching how to create it on DigitalOcean. You're creating how to create a Kubernetes cluster. The first few articles are from DigitalOcean community. Most of these articles, they are written not by DigitalOcean employees, they are written by the community, and you can even like help, they have a program where if you write an article on the DigitalOcean community, they donate a part of that. So it's a pretty nice thing. There's a very good community, so any kind of help that you need on server side, installing things on Linux, how to do that, all that stuff, that's all available on DigitalOcean community setup. So, okay, that was it, I guess. If you want to hit us up on Twitter, that's Champion Swimmer is me, Coding Blocks handle is that. And Everything that we do at Coding Blocks is open source. All of our backend front-end, all of this stuff is open source. How that IDE runs everything, you want to check it out. github.com/coding-blocks. You can go there. You can try out any of our things, our apps, our front-end, backend, all of that is open source. You can try any of that out. Thank you.